For years, astronomers have been watching one of the most brilliant and enigmatic stars in our sky, Betelgeuse, the red supergiant standing on the edge of collapse. Everyone knew its end was coming. They just didn't know when. Now, the James Webb Space Telescope has captured what few believed we'd ever witness, the precise moment Betelgeuse began to explode. A stellar death, a cosmic shockwave, a window into the raw, violent power of the universe itself. This isn't another deep space image. This is a once-in-a-lifetime event, the closest supernova humanity has ever observed. And what Webb saw has rewritten everything we thought we knew. Betelgeuse, resting in the shoulder of the Orion constellation, is no ordinary star. It's a red supergiant over 700 times larger than our Sun and nearly 20 times as massive. For decades, scientists have known it was unstable, swelling, pulsing, and dimming unpredictably. In 2019, it suddenly faded, sending waves of speculation through the scientific community. Was this the end? Was Betelgeuse about to go supernova? Now, Webb's high-resolution data has deepened the mystery. For the first time, we're seeing the real-time indicators of a star in collapse. Enormous energy surges, convective turbulence across its surface, and magnetic fields twisting themselves into chaos. Betelgeuse isn't just dying, it's transforming right before our eyes. The James Webb Space Telescope has been locked onto Betelgeuse for months, using its unparalleled infrared vision to look deep into layers that no previous observatory could penetrate. The images it's sending back are staggering. Convective bubbles the size of Jupiter are bursting across the star's surface. Massive plumes of superheated gas are streaming into space at unimaginable speeds, and hidden within the light spectrum, a shockwave signature is moving through the star's outer layers. For the first time in human history, astronomers are watching the actual physics of a star tearing itself apart. This isn't a simulation. It's real-time cosmic anatomy. A supernova unfolding just 642 light-years away from Earth. Unlike the distant supernovae we usually detect in far-off galaxies, Betelgeuse is close, cosmically speaking very close. Its explosion will one day blaze so brightly it could be seen even during daylight, brighter than the full moon. But more than that, its proximity gives scientists an unprecedented opportunity to study the death of a star up close, to observe how its core collapses, how elements like carbon and oxygen are forged, and how shock waves reshape the surrounding space. What Webb has captured isn't just a death, it's creation in reverse. The same forces that gave birth to the elements of life are now being laid bare. We are witnessing our own cosmic origins, played backward in fire and light. The explosion of Betelgeuse is more than a spectacle. It's a revelation, a key unlocking the hidden mechanisms that shape galaxies, planets, and the very building blocks of life. With Webb's advanced instruments, scientists can now model the final stages of stellar evolution with unprecedented precision, revealing how stars die, and maybe even how to predict such events before they happen. This is not just science. This is cosmic revelation. The moment humanity looked into the abyss of time and saw light fighting its way out. But the story doesn't end with the explosion. Betelgeuse's death is sending shock waves across space, literal ones. Webb has already detected the early ripples, high-energy particles racing outward, heating nearby gas clouds and reshaping the star's dust halo. And there's more. Something subtle but monumental, a gravitational shift. Even from 642 light-years away, the collapse of Betelgeuse's core may have generated gravitational waves, the same kind we've only just begun detecting in recent years. If confirmed, this would be the first time humanity has directly linked a visible supernova to gravitational wave data, rewriting everything we know about the connection between light, matter, and space-time itself. As Betelgeuse collapses, one of the universe's oldest questions reemerges. What remains after a star dies? Will it become a neutron star, a black hole, or something entirely new? Webb's data suggests this collapse may not be symmetrical. There are disruptions in the magnetic field, plasma voids, and regions of fallback, where ejected matter is pulled back inward instead of escaping. Some astrophysicists believe Betelgeuse may be forming a transitional object, something between a neutron star and a black hole, a phenomenon that has only existed in theory. If confirmed, it would be the first direct evidence of an entirely new class of cosmic object. Naturally, people are asking, are we in danger? The answer, thankfully, is no. Betelgeuse is too far away to harm Earth, but that doesn't mean its explosion won't have an impact. Its supernova will unleash a storm of high-energy particles, gamma rays, and expanding electromagnetic waves that could alter cosmic dust clouds, influence nearby star systems, and even change how light from other regions of space reaches us. Webb's instruments are now tracking the velocity and spread of this radiation front in real time, because even though we're safe, the event could permanently alter the optical structure of our local galactic neighborhood. Betelgeuse is immense, ancient, powerful, and yet, it's mortal. Its death is a reminder that even the brightest lights in the universe eventually fade. What Webb captured isn't just the end of a star. It's a cosmic mirror reflecting our own impermanence. Everything that exists must end. But through that end, new elements are born, new stars ignite, and new worlds form from the ashes. This isn't destruction, it's renewal. The cycle of cosmic rebirth playing out in real time, and we are the lucky generation to witness it. Amid the vast data collected by Webb, scientists also found something unexpected: rare elements, ones never seen in such abundance before. Alongside carbon, oxygen, and iron, Webb detected traces of technetium and yttrium, elements forged only in the most extreme stellar conditions. Why does that matter? Because analyzing the ratios of these elements allows scientists to trace the life cycle of matter itself. From the cores of dying stars, to the dust that forms planets, to the atoms within you and me, Webb isn't just recording an explosion. It's decoding the cosmic script of existence, how life becomes possible. Betelgeuse will never return. Its place in Orion will fade into a glowing cloud of debris, a nebula of its own ashes. But its death is not an end. It's a gift of knowledge, of elements, of perspective. It reminds us that our sun, too, will one day fade, that even the most eternal-seeming lights have a final act, and from those endings come the seeds of everything new. Without supernovae, there are no planets, no oceans, no life. Thanks to the James Webb Space Telescope, we can now see that truth unfold, from fiery collapse to the raw materials of creation. In the cold silence of space, 642 light-years from Earth, a star has ended its life. Not quietly, but in a blinding final roar that traveled through the dark for centuries until it reached us. Thanks to Webb, we didn't just see it, we understood it. We watched the signs, the collapse, the detonation, not as myth, not as legend, but as reality. Betelgeuse didn't die in vain. In its final breath, it gave us answers to questions older than humankind itself. Where do the elements come from? How do stars live and die? And what will become of our own sun? In that fading red light, Webb has captured more than a supernova. It has captured our origin story and a glimpse of our future. So now, we ask, what else is the universe preparing to reveal, and are we ready to witness it? Let us know what you think in the comments. Was this the most important stellar event of our time? And what cosmic secret will the James Webb Telescope uncover next? Because this isn't the end, it's the beginning of what comes after the stars.